Hello everyone and welcome to my new video. In this video we are going to talk about how to analyze bursty traffic in your network. Now most of you might have experienced situations in the production environment where you have noticed that there is QoS drops or heavy output drops on the interface and you do not know why it's happening, even though you see that the traffic rate of the interface is way below your QoS policy or way below the capacity of the interface or speed of the interface. But even then, you're seeing a huge amount of drops on the interface itself. And that's where you might want to understand if there's actually some bursty traffic coming in or going out, which is impacting your QoS or impacting your buffer on the interface and causing those drops. So this is an ISXE box. It's a virtual environment, but I just want to show you what you usually do when you're seeing drops on the interface. So if you look at the show interface gig 1 output, even though it's complete that the interface is down, but you might see, you usually see the traffic rate by default an average of 5 minutes, right? And it's not the correct timeline to analyze the traffic pattern, but we always can understand the better traffic rate averaged out to the lowest of 30 seconds. So we can go into the interface and say gig 1 and say load interval 30. Which will give you the timeline of or an average output of the interface, and we can unshut the interface, and this will give you the output of the interface to be an average of 30 seconds, the last 30 seconds. Now, this may still not depict if your traffic is high enough, or if you're receiving a bursty traffic, because the devices do not show you the millisecond rate of the traffic pattern that is entering or exiting your network. And at that point, you might see the drops here because of your input buffer, or you might see the drops on the output direction. Mostly you will see the drops on the output direction, not on the input. That's where you assign your QoS policies. And if you're seeing your output drops, and if you, the first thing that would come to your mind is, do you have QoS policy enabled on the interface, and which is either wrongly configured or misconfigured and causing those drops. But you will eventually notice that the traffic pattern is pretty low as compared to what your QoS policy has been accounted for or is shaping for. So in those scenarios, it is always better to perform a packet capture. Now I'll move to the packet capture. This video I was planning to primarily focus on the packet capture and Wireshark tool itself to analyze how you can capture or how you can look for bursty traffic on the interfaces or on the devices in your network. So let's move to the packet capture. So I have a packet capture file here, which is a pretty big file. It's around close to 4 gig packet capture file, and it's from one of the production environments that I've worked on. So if you look at the traffic pattern, it's mostly either TCP traffic, or there are other bunch of traffics that we'll be seeing here across NBSS and all those things. But this doesn't depict the exact reason, or this does not tell you, well, you can, first of all, you cannot analyze all the packets that are coming on to your network devices or exiting your network devices if there's a bursty traffic. You cannot go through each and every packet, and especially in this scenario, if you look at it, these are like 4.5 million packets. These are pretty high number of packets that we cannot really analyze in a short amount of time. So what we can do is we can go to the statistics section and click on Ayah Graph. Now it's a very neat tool that analyzes all your packets and plots them on a graph, and it's a very slick tool to have. So if you look at this now, all these packets are being analyzed by this Ayah graph, it will be put into the plotting graph on the screen. So let's give it few couple of minutes. In those couple of minutes, you will notice that we have a graph that is drawn out of those packets. Now, what we have on this Ayah graph, let's talk about that for a minute. In this Ayah graph, we have packets per second per 1 second rate. If you notice, it's one per 1 second, and here is you have the timeline, so which is in seconds. Um, if you also look at closely the interval, it's by default selected at 1 second. Since there are high number of packets in this packet capture, I'm going to give it a minute before changing anything. But we are measuring the traffic using the packets per second. So this will give us a fair picture of how many packets per second arrived on the interface or exiting the interface in a per second interval. Now this is per second. Remember, on the device we were looking at 30-second average, and this is per second. So it gives us a better picture, but again, not a complete picture. But let's take a look at it. So now we have our plotting graph ready, and it shows the different ranges of the traffic. We can see in a per second we have hit even up to like above 15,000 packets in a second, which is pretty high. But number of packets doesn't depict or doesn't help you analyze properly the bursty nature of the traffic. Now, in order to get to the millisecond level, you can go to the interval section and change it to 1 millisecond, and that will recalculate or recalibrate the whole packet capture that you have done and put it on the Ayah graph. Now, this will give you a per millisecond average or per millisecond rate of traffic that is incoming or outgoing off the network or the devices where you have performed the packet capture. If you look here, this is somewhere down the line averaging out to 360 plus packets per millisecond. Remember, this is now we are talking about milliseconds, and the timeline that we are looking here is on a second scale. So within a second, like, you have huge number of packets and huge number of bursts. Now, if for some reason you have an interface which is supporting 100 megs, right, or you might be wondering, is it exceeding? It is not exceeding. You do not know at this point. So in such scenarios, we might have to recalibrate further on this Ayah graph. But let it complete its analysis. We'll give it another minute or two to complete the progress of all the packets and see what we can understand or analyze from this Ayah graph for packets per millisecond. For such huge set of packet captures, I would suggest we have all the other resources freed up on the laptop or on the system, because this Ayah graph and even loading these huge packet capture files on the Wireshark tool can add up to a lot of resource consumption. So I would prefer closing down on some applications which makes it easier to load all the packets and make it easier for us to analyze the traffic or the packets that we have captured using this. What we usually do when we're performing packet captures is we perform a span session. I'm hoping pretty much everybody watching this video knows about it. So we span the interface that we're trying to capture the traffic on, and we redirect that traffic or the span or mirrored traffic onto an interface where our host is connected with a Wireshark-like tool attached to it or installed on it. And when the traffic is received on that interface, we capture it using the tool, and then we can later on analyze the traffic and see what is going on. If you look at this traffic pattern while it's still loading, you might notice that there were some spikes on the network or on the device in this region, like within like 1 hour. and then it was a low rate of traffic for some time, and then it spiked again. So this kind of also gives you a pattern on the network on what is really happening. So it might be when you're troubleshooting bursty traffic issues, you might also want to consider what time of the day the problem is happening. If it's happening during night hours or during production hours, during any other time of the day, you might want to consider that before getting on to, because performing packet captures is not always helpful, and it's not easy as well. So you might be running packet captures. First of all, you cannot run the packet captures throughout the day, right? It's not scalable and feasible as well. Second, you might run a packet capture, but at that time of the day, you might not be seeing a high volume of the traffic, either on the production, maybe on the non-production hours. It might not make sense. So it's important we first analyze the traffic pattern on, or the average out of the interface traffic on the device itself, on say for on Cisco devices, and from there on we try to see, okay, this time of the day the traffic was pretty high, and the other timelines or other hours, the traffic is not that high. So that might help you, give you a better idea on when to perform the packet capture to see if the drops that you're seeing on the interfaces are really due to bursty traffic or not, and especially during those specific hours where the 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 rate of traffic is spiking up pretty two or three or more number of times, like double the traffic rate or triple the traffic rate. That's what you should be looking at. So the loading is complete. So now we have the traffic. So this is, if you look closely, this is close to, I believe, 250 seconds of of traffic. So more than 4 minutes of traffic that we have here. Now this is just showing us the traffic pattern in 360 packets per second. The packet size is not conclusive here. So what you can do is, this tool also gives you an option to convert that into bytes or bits. So if you look at, if you want to understand the bursty nature of the traffic, you might want to change from packets to bytes. And once you do that, and let this recalibrate, this Ayah Graph recalibrate the whole graph to make it more understandable, we can then analyze the packets pretty easily. So let's give it another few seconds. If it's already recalibrated, then we should be fine with it. I think it got recalibrated. Okay, so yeah, this looks that it has been recalibrated, which was pretty quick. So in this case, now if you look at it, even if you have configured like 100 meg allowance for the outgoing interface for the shaper or the cures policy, your 100 meg will come somewhere around 100,000 here. And you are having traffic of close to 300 megs, which is this bursty traffic telling you about. Now, how do you calculate if it's the bursty traffic or not? Let me show you a link. Give me a second. And I have a link very handy. Let me bring my browser here. Okay, it's asking for login. Let me log in and have logged in. Okay, so now I have the traffic here with me, and well, my page with me, and it shows you how to analyze the bursty nature of the traffic using Wireshark. Now, one important thing that I wanted to highlight on this page was how link speed of 100 Mbps can be drilled down to 100,000 bits per millisecond, or like 100 million bits per second. Now, if you want to look at the traffic pattern, here we have calculated bytes. If you wanted to look at bit rate, we can do that as well. It will give you a better understanding of the traffic pattern. So it is what we are seeing right now. So your 100,000 bits per millisecond is somewhere around here. So this is how you can analyze your packets using the packet capture on the Wireshark, and use the Wireshark tool to perform a deeper analysis of your bursty, if deeper analysis of your network traffic, and see if there's bursty traffic in your network. Hope you find this video useful. Keep following my my YouTube channel, and hope you enjoyed it. Thank you.